So this is our fifth video on adaptive immunity. We just talked about in our fourth video the cellular immunity, which is cell-mediated, and now we're going to talk about humoral immunity, which is antibody-mediated, or it's contained within the humors. So humoral immunity is a more indirect method of defense than cellular immunity because it's within the fluids rather than within the tissue itself. B lymphocytes in the humoral immunity produce antibodies that bind to antigens and tag them for destruction by other means, whereas cellular immunity attacks the enemy cells directly. And again, just like cellular immunity, it works with those three R's, which were recognition, response, and remembering. So recognition, attack, and memory. So recognition in humoral immunity is by B cells. So immunocompetent B cells has thousands of surface receptors for one antigen. Again, remember when it's called immunocompetent, it means that it's able to recognize antigens. And they can be naive immunocompetent, which means that they've never been exposed to a specific antigen, or they can be educated. So activation of the B cell will occur when antigens bind to several of those receptors for the antigen, and that will link them together and take them and they'll be taken into the cell by receptor-mediated endocytosis, which is pretty much the same as phagocytosis. Small molecules aren't able to be antigenic because they can't link multiple receptors together. So generally speaking, you won't get haptens initiating this immune response, but it does happen. So B cells then process and digest the antigen, just like antigen-presenting cells would do. And it links some of the epitopes to the MHC2 proteins. Remember, the epitopes are the important part of the antigen where the antibody is able to bind, and they can be incorporated into the MHC2 proteins, which are those signaling proteins that distinguish self from non-self, as well as infected self cells. So these antigen epitopes are with the MHC2 protein complexes. These are displayed on the cell surface. Usually B cell responses doesn't go much further after that, but if they are bound by helper T cells to that antigen MHC protein complex, then the bound T helper cell will secrete interleukins that activate that B cell. Remember, interleukins are cytokines, which are kind of like immune hormones. So this will trigger what's called clonal selection. If you remember from before, clonal selection is when you just make clones of yourself, basically. So B cell will then undergo mitosis and get and make a bunch of different clones of itself that are programmed against that same antigen. Most of these B cells will then differentiate into plasma cells, which are larger than B cells and have a large amount of rough ER so they can aid in protein synthesis. Plasma cells, as you would expect, would be found within the plasma. And these can secrete antibodies at a rate of 2,000 molecules per second during their very short lifespan. So that makes sense that they would have a large amount of rough ER because they're synthesizing proteins like crazy. So the first exposure to an antigen is going to will trigger the production of IgM antibodies, and then that second exposure will trigger IgG antibodies to be created. Antibodies will then travel through the body and blood as well as other body fluids so that they're able to recognize the antigen. So with attack and humoral immunity, the antibodies bind to the antigen, render it harmless, and tag it for destruction. So basically, they're tagging it for other cells to destroy it. They don't do a whole lot of the destruction themselves. Memory in humoral immunity is also quite important, so that some B cells are able to differentiate into memory cells, much like the T cells do. And this allows you to remember that antigen for subsequent exposures. So here we see a diagram of that clonal selection and the events of the humoral immune response. So it starts with antigen recognition, then presentation, then clonal selection where it divides rapidly, then differentiation where it either becomes plasma cells, which most of them do, or a memory B cell. And then the attack is the plasma cells just synthesizing and secreting that antibody into the plasma, which then binds to the antibody on the harmful cell and tags it for destruction later. So here you can see a difference between a memory B cell or a regular B cell and a plasma cell. So what is notable about the plasma cell is all those lines. Those are all rough endoplasmic reticulum. So you can see there's quite a bit of protein synthesis going on. So during humoral attack, the antibodies can have 4 different mechanisms of attack against antigens. And these are neutralization, complement fixation, agglutination, and precipitation. So during neutralization, antibodies are able to mask the pathogenic region of an antigen, so it can render it harmless and it won't exert so many effects throughout the body. In complement fixation, IgM or IgG, which are immunoglobulins, bind to the antigen, change the shape of that antigen, change their own shape, and initiate complement binding, which, if you remember, that can lead to inflammation, phagocytosis, immune clearance, or cytolysis. Remember when we talked about complement, that it has 4 different mechanisms, but the most important mechanism is cytolysis, where it basically punctures a big hole in the cell. This is the primary defense against foreign cells, bacteria, and mismatched red blood cells. Remember from our blood lecture, there are humoral attacks if you are being transfused with the wrong type of red blood cell. So during that humoral attack, agglutination also occurs. So an antibody has 2 to 10 binding sites, and so that it's able to bind to multiple enemy cells, immobilizing them from spreading. So they basically make them agglutinate. They kind of gather them all up. And this will enhance phagocytosis by creating bigger bites, meaning that each one macrophage can eat more of the enemy cells. There's also precipitation, so that antibodies that bind antigen molecules, not full cells, will create an antigen-antibody complex that precipitates, allowing them to be removed by immune clearance or being phagocytized by eosinophils. So again, that's kind of the same thing, but it's when there's not cells. So here we see agglutination, which is the top, and precipitation at the bottom. So agglutination occurs when there are cells involved, whereas precipitation is when they are just antigens and no cells involved. So with humoral memory, we have the primary immune response, which is the immune reaction brought about the first exposure to an antigen. So this is the first time that you're exposed. Protective antibodies are delayed for a couple of days while the naive B cells multiply and differentiate into plasma cells. So these naive B cells are learning about that antigen and how best to protect against that antigen. So they're creating antibodies. So then they differentiate into the plasma cells. When the plasma cells produce antibodies, the antibody titer, or the level of the antibody in the blood, will rise because they're producing massive amounts of these antibodies. So like we said, IgM will appear first, will peak about 10 days later, and declines after the antigen's been cleared, or mostly cleared. IgG levels will then rise as IgM declines, but the IgG titer drops to a lower level within a month. So you get both IgM and IgG helping out with this primary immune response. So the primary immune response will leave your body with an immune memory of that antigen. So during clonal selection, some of those plasma cells, some of the naive B cells become memory B cells, whereas most of them become plasma cells. These are generally found in the germinal centers of the lymph nodes, so just remember that they're found in the lymph nodes. And they allow the body to mount a quick secondary response. So during the secondary response, if you're exposed to that same antigen, plasma cells, or plasma B cells, will form within hours, and your IgG titer will rise sharply and peak a few days after. The response is pretty rapid, and that means that the antigen has little chance to exert a noticeable effect on the body generally, so that you'll have no illness resulting. Um, Low levels of IgM are also secreted and then quickly decline. And these IgGs remain elevated for a couple of weeks to years, which confers long-lasting protection. So memory doesn't last as long in the humoral immunity, which is B cell generally B cell mediated, than they do in cellular immunity. So here we can see these immune responses. We see the peak of IgM and IgG during that first response, and then the secondary response where it's a lot more robust. They can produce more antibodies and quicker.